Assalamu alaikum and welcome back. Today's topic is expected value and functions of a random variable. Suppose we have a random variable x with the sample space given as -2, -1, 0, 1 and 2, so 5 different values. Let's say all these values are equally likely, so the PMF of x would be then 1 by 5, 1 by 5, all of the probabilities of all of those possible values is the same. Now let's say we have a function of this random variable z, right? So z is a function of x, and this, let's take a simple example. So this function is x squared, so z is equal to x squared. So now looking at this function, it's easy to guess the sample space of z. Okay, so for each value of x, z is the square of it. So whenever x is -2, z would be 4. Whenever x is -1 or 1, the value of z will be 1, and 0 is 0. So the sample space of z is 0, 1 and 4, right? That was easy. Now let's say we're interested to find the expected value of z. Okay, so as we know from the previous lectures, the expected value of any random variable is found by multiplying that random variable, the values of that random variable, by their respective probabilities. Okay, or all values are fine, right? What if we don't have the CDF of z? In this case, we don't have the CDF z. We can find out from the CDF, from the PMF, sorry. We can find out the PMF of z from the PMF of x. But let's assume that we don't have the PMF of z. Is there a way we can still calculate the expected value of z? It turns out that there is a way, and that is if we, by using the PMF of x, okay, all possible values of x, we can find out the expected value of z by multiplying all the values in the PMF of x by the function of x, the same function that generates z. So for example, in our case, so the first value of x is -2, so multiply -2 whole squared, right? That's the function. The function squares the values of x into the PMF, into the probability of getting -2, which is 1 by 5. Okay, plus the next value of x through the function, which is squaring it into 1 over 5, plus the third value into 1 over 5, and so on. I'll just do over here, one I have already done to 2 squared into 1 over 5, which comes out to be 4 over 5 plus 1 over 5 plus 1 over 5 plus 4 over 5 is 10 over 5, which is equal to 2. So without knowing the PMF of z, without first calculating the PMF of z, we are able to find the expected value of z by this formula. Okay, now you may ask, what's the proof? How can you say that this gives you the PMF of the expected value of z? So the proof is, let's try to prove it basically. So g of x, we want to prove that this actually equals the expected value of z, right? So this summation can be divided into two summations, because as we know, that in our case the relationship is such that multiple values of x produce single value of z. Here you can see -2 and 2 both produce 4. Similarly, -1 and 1 both produce 1, and here 0 produces only 1 or 0. So there can be multiple values of x that produce a single value of z. So first of all, let's take the first summation over all possible values of z. Okay, so I belongs to sz, right? All possible values of z. Now for each possible value of z there can be multiple values of x. So it's a j, different, and those multiple values of z, multiple values of x, different or multiple values of x that can produce the same 4. So all those values are summed up over here, and then multiplied by the z, which is the g of x basically. Now if we sum the probability of those multiple values of x that give us the same z, for example -2 and +2, if we add the probability of getting -2 and +2, we get the probability of getting 4, right? Similarly, if we add the probability of getting -1 and 1, we'll get the probability of getting 1 for z. So because our example is simple, so it is easy to see that if we want to calculate the PMF of z, it is easy. What is the probability of getting a 0? Z will only be 0 when x is 0, and x is 0 with probability 1 over 5. So probability of getting z equal to 0 is also 1 over 5. Okay, secondly, what is the probability that z is equal to 1? Z will be equal to 1 only when x is either 1 or -1. Okay, in both cases z will be 1. So the probability of z equal to 1 will be sum of the probability of x equal to 1 and probability of x equal to -1. So then that will be 2 over 5, right? Similarly, the probability of z equal to 4 will be, z is 4 whenever x is 2 or -2. So the probability of z equal to 4 will be the sum of the probability of x equal to 2 or -2. So this is already 2 over 5. So you see, to get probability of a single value of z, we are potentially adding all the values of x, probability of all the values of x that produce that value of z. So that's why the sum is. And by summing all these values, we get the PMF of z itself for the different cases of z. Okay, so if we replace that, I belongs to zi into p z of zi, that by definition is equal to expected value of z, right? So that's why this is the proof that expected value z can be found out using the PMF of x.